I want to show you some output of what I'll characterize as some of the most sophisticated work we've done in the marketplace that is very unique and has tremendous intellectual property that we've created. A lot of it is the brainchild of Irfan and Carl, and it's very much focused on resource management and resource utilization. So one of the first analytics we built at CloudPhysics, if you may remember, because it was the reason we were in the Fusion I/O booth and the domain expertise that we all carry initially in the team was all around storage. And the problem that we were trying to figure out was something that's now become, I think, pretty common, although it's still very difficult to do with data, which is, hey, I've got these workloads and they perform in a certain way. How much cache or how much solid state disk do I need to provision to these things to make them perform? Because if you provision too much, it's going to be wasteful. And if you don't provision enough, the workloads either create contention or they fall off the cliff onto slower media, if it's a tiered storage system. And you end up having performance problems. So it's kind of a Goldilocks problem. I need just enough in order to meet my customers' needs. So I put this challenge out, and we formed a partnership with Fusion I/O to build an analytic that traced workloads, basically through the vSCSI stats interface, which Irfan originally wrote back in 2006, and I know you guys have all used. That interface, though, is difficult to introduce and do, you know.
You have a talent for understatement.
It's my Midwestern upbringing. But it's a very difficult thing to do and not perturb a workload, as well as do this economically, where this sheer size of a workload trace becomes insurmountable when it comes to the actual cost. And so we built this tracing capability originally, and we were able to do this non-disruptively initially, but the traces became unpredictable. Meaning we would go and we would trace a workload with our analytics platform, and you would end up getting like a 500 gigabyte file, right? And so when we would get the Amazon bill, we would end up charging a customer, say, $200 for the analysis, but it would cost us $500 in Amazon. So because
you got to make that up on volume.
Yeah, a little thing called money got in the way of realizing that. And so we went back to Carl and Irfan and team and said, look, you got to solve this giant computer science problem, which is don't perturb the workload, do it with a minimal footprint so that you do not lose fidelity of the trace. And oh, by the way, do this in constant resource space so we know how much it's going to cost every time we run a workload trace. Good luck, right? Well, Carl disappeared for the better part of a year and came up with something that he announced at FAST, the Usenix Storage Conference, a year ago. And we announced a technology that we've now embedded in our platform, as well as in a library that is currently going to market with different storage platforms. And at the core of this technology is what's called a miss ratio curve. And you guys probably know this better as a hit ratio curve, and it looks differently because the XY axes are flipped. But the academicians require MRCs as the way to look at this problem. And what you have is the miss ratio. So lower is better, fewer misses in a cache or on an SSD. And the size of the cache determines what that benefit's going to be. And so when you trace workloads, what's really fascinating is that you get a tremendous amount of variations that start to look like fingerprints of the working set of an application. And it's pretty amazing because I've seen thousands of these now. You can kind of do the genius thing by looking at all these workload traces and go, oh, that's Exchange. Oh, that's SQL Server. But they actually do have fundamental fingerprints. And so we have thousands of these traces from customers that we work with. And what you can see here is to say, look, if I didn't really see a benefit in the provisioning of cache until I got out here close to 128 gigs, and then, down to about 84 gigs. And then, just by adding a small increment of cache, I saw a tremendous benefit because the missed ratio curve between here and there generated a far greater number of hits. So my performance was better. And the result of this is that you get a great understanding of how much cache is going to predictively deliver performance based on the types of workloads that you're running. So you can go into a customer's environment with our analytical service, and you can literally determine by looking across all of the workloads whether or not that customer is going to benefit from the introduction of all flash arrays, hybrid arrays, or no flash, and you stay old school spinning Rust. And so we have some data that's going to surprise you from our global data set that talks about this.
And also with hyper-converged, where the working set ratio has to sit in SSD, this is
absolutely
exactly the kind of...
So as the first product manager on vSAN, I will painfully attest to that fact. Really bad things happen if it falls off of that.
And it's not easy to find out yourself.
It isn't, but you can with this. So if you're sizing exercises for any type of storage platform, I really encourage you to come talk to us about how to conduct one of these assessments. Here's what it looks like, from, and I don't know why we didn't do this. I was a big advocate of when we were in our first office spaces, like just doing a paper walls of workload traces. I kind of did that at home as we started to print them out, but my kids thought I was crazy. But you can see there is, first of all, what you're looking at here are a series of workload traces that were the result of our initial tests from real production workloads. And the red is our tracing accuracy relative to the dotted line that you probably can't really see. And the dotted line is a full-time trace. So what the team and Carl specifically have been able to do is, with very minimal amount of sampling of a workload trace so it doesn't perturb that workload, you don't lose any fidelity in what the actual trace looks like. So you can see very quickly, like, you're not going to get much benefit by adding more cache until you get out here with this workload.
Right.
This one, you're not going to get much of anything, right? And so every workload has a unique...
T15 pays off right away.
Yes. Yeah. So knowing this, and so we have ways to give you the data where this is consumable. I'm just putting the visual up here so you see that the world's wonderfully differentiated. And workloads, understanding these workloads is, I think, at the core of a lot of the magic you guys can exercise in understanding the customer and their workloads. This is equivalent. This is understanding the potato chip that we started this with. How are the resources that we configured, how are they being consumed? Well, this is the consumption model that gives you that other side that today no one really sees. So this is, as I said, is not really seen in the marketplace today. And now I want to shift to another topic that goes from where we just were, which was more of a micro focus on caching analytics, to a macro focus now on a new concept that we've introduced to some of our largest enterprise customers that I wanted to introduce to you guys and see what you think. Again, previous work and this work were based off of that same platform that I've been talking on and on about here, our data lake. The level of data science that's gone into this is something that really our industry hasn't seen, and we would love to work with you guys in what the underlying logic looks like here to do some of these tests. In this case, we call this service quality analysis, and it's something I'm going to stand and proclaim that I would love to see if you guys agree or disagree with this and understand why you would agree or disagree. And I'm claiming that there is one golden metric. It's called latency. Latency from the infrastructure. So an application makes a call, and the infrastructure responds. And the time between the call and the response, where the response is governed by and constrained by how CPU, memory, networking, and storage are combined and perform, I believe, and I'm ready to do verbal jujitsu here, that everything we do in our careers in this industry is ultimately reduced to whether or not we're producing latency that is predictable and consistent.
Here I was all set to argue with you.
I love it. Wait.
Congratulations.
So I'm proclaiming it. I'm throwing it out there. This is the golden metric. Where, let's say you're an SVP of a global pharma, and you have to report to your CFO or CIO who has zero understanding of your budget or what IT really does, only that it just keeps consuming more and more of your budget. And that there is no way for me to measure whether or not you, as that SVP or CIO, is actually doing your job. You just keep coming back to me with spreadsheets and PowerPoint presentations around KPIs that say, this is what I got out of CPU, this is what the investment on the storage platform looked like. There's no way that CIO today can actually determine with one metric that the CFO is going to understand whether or not the CIO is doing their job. And I'm saying there is. It's called latency. And latency has to be predictable and consistent. Otherwise, the business will suffer. So then, if you believe that or don't believe that is one question.
I believe that, but there are latencies you can't measure. How long did it take to get the new application?
Okay.
Is also latency.
This is very interesting. So,
from customer demand to customer satisfaction time is still latency.
Like in a pizza. Request to it's at my door.
Yeah.
So let's deconstruct what you guys have just said. This is a really interesting one. And then I'll start to explain this Michigas in a second. All right, so.
Man after my own Yiddish heart.
Exactly. My grandmother,
too, Howard.
my grandmother still lives. So here you have the application. It's generating its exchange. It needs to be performing 20 milliseconds consistently for it to be usable. But it's now performing 40 milliseconds. There's a procurement request. The customer is saying, this thing is freaking slow, make it go faster.
Oh, that you can measure because that's something existing as code. But,
yes.
But we need a project management system we have a project management system time.
Yeah, the phone call.
Is immeasurable by you because it's not electronic
Not encoded.
till the end.
Fair enough.
Not instrumentable.
You need an instrument layers 8, 9, and 10.
Yes.
Okay, well.
8 is politics.
We're back in the matrix.
9,
We're back.
9 is geopolitics.
We are totally.
10 is metaphysics.
We are in the matrix, for sure. Yeah, absolutely.
Sorry, 8's people. 9 is process, 10 is politics. Anyway.
But this is, okay, so this is a very good point. The path I was going down is that if this thing is moving at 40, 50 milliseconds, and your team comes in and says, look, I can't get it down to 20 milliseconds, I have to go add more flash. So now there's the time between when you make that decision and the flash actually shows up and where it shows up and making sure that it's provisioned correctly. Okay, so now you have a latency between when that request was made and when the deployment has to happen on the floor so that the latency starts to come down. This curve, what we call a service quality measurement curve, an SQM or an SQC, tracks that on a daily basis. It determines whether or not you are actually delivering on latency in a way that's consistent, using the methods Chris was describing as a set of histograms that take latencies from all the different resources and combine them in a way that our team is uniquely suited to figure out to roll it up to this global latency, but a latency that also can be deconstructed into different constituent parts based on how you want to drill into it. So here is the global latency of one of our customers.
And now we plug it into purchasing and service now, and we get to every move you take, every breath you take.
Yep. And you start to determine. Now, this can be good and bad, right?
Oh, yeah.
You can show really, because
Big Brother was a good idea until Oceania was always at war with East Asia.
oh my God, it's true. But what you see here, this is actually a curve that's derived from a histogram. And what is happening here is these are the outliers that are spikes in latency that happen on a very small percentage of instances of actual
It's a log
events.
scale. There are very few that are on those extremes down there. That
Yeah, it's actually smaller, but it's visually put out there so you can see the differences. So
We told the last guy we grok log scale.
Okay.
good. So there's You can't see it, but because it's actually colored. These are also done over time, right? So there's several lines, and so if you start to see different lines for different resources start to diverge in different ways, you've got a problem. There's something going on there that you have to go poke around in. Now, what we've done with these curves showing latency is also map them to utilization curves. So you look at your overall infrastructure and you go, wait a minute, if my latency is rising and my utilization is flat or declining, am I doing my job?
No.
No. If my latency is flat and my utilization is rising, am I doing my job? You are.
Yeah.
So by looking at the direction these curves take, you can kind of do macroeconomic analysis, is what I call, because my background was in econ, of what's going on in your infrastructure to figure out, am I generating effectiveness in what I'm doing? If I increase my budget and my cost curve starts to rise locally, but my utilization goes down and my latency is going up, right? You'll get chopped if you continue that way. Now, on the other hand, if your cost curve remains flat and your utilization is rising and your latency is flat, you need to take that to the CIO and the CFO and the CEO to say, look, I'm doing my job.
How are you getting the cost metrics into your graphs, though?
So we'll talk about that later. So there's cost, and you guys are very familiar with the pain of collecting costs locally. We'll talk about that in the...
But basically, it means that there's a way you can always associate cost. I mean, even internally, you would know how much hardware costs, and the platform's going to tell you need servers and that kind of thing, and you can work it out. Okay.
It's a big logistical problem. I know you guys have written about this in many ways, and so, but cost alone isn't going to tell you whether you're doing your job. You may be spending money as a CIO in a way that makes complete sense once it's measured against what your infrastructure is producing. And so we believe this framework of thinking, by reducing it and creating it around what matters most, around the single golden metric of latency, is a way for the management of IT to start thinking about how it produces and supports the business.
That's also an interesting, because you can start adding value, not just cost. So, of course, an all-flash array is going to solve my problem.
Yep.
But actually, I don't need necessarily an all-flash array. I could get a hybrid array, which would be 2/3 of the cost, and that would maintain my latency for a certain amount of time.
So what you're saying is, once you introduce data into any type of operational process, and that's what I started the presentation with, data is being introduced in every industry, and the result of that is operational efficiency and safety. So what that calls into question is a lot of historical habits, including stuff that I'm guilty of as a former SE, of coming in and saying, oh, we can solve this problem with hardware. If you have data in the right context, that may not be the answer. That actually could create less effectiveness and may actually demonstrably show that you're not doing your job by increasing cost at a way that is just unacceptable to the business. And so this is transparency at its heart, right? And it's shining light in our domain that just has not existed before. And so,
I'm trying to get a sense of, in terms of you selling this product, is this the end goal, the prime value of where you're trying to take this, or just a nice side benefit?
So what's interesting is that this is not on the platform per se as a product. We are doing this in concert with select customers and partners like yourself. And right now, we are in the throes of productizing this as we learn more and more about what's most meaningful around this one golden metric. And it's very instructive, which is why I was excited to introduce it to you guys, because I think your creative thinking around this will help guide us as to what other metrics we should associate with this. And so this is a service offered off from our platform with our data scientists actually assisting you. So if you have a partner or you want to exercise this on your environment in which you currently work, contact Chris or me, and we can arrange for this analysis to be done, literally.
A common use is immediately prior to a major infrastructure overhaul. Let's see the before and after effect of the change. So do it over 8 weeks at the end of this quarter, then 2 quarters later do it for 8 weeks and see if there's been an improvement. That's a common, not the only, but that's a common use for this.
Yeah, so this is a variation to the previous slide in that it's focusing strictly on virtual disk latencies. The table beneath it.
Read only.
Yeah, read only. But this, I think, is more instructive, right, where these are snapshots of the latencies at different thresholds that have been taken to determine literally, are you over time seeing improvements or declines in the maintenance of latency? And so if something is, it's going to change because the workloads change, and understanding the response of an operational team to these variations is very important to understanding the effectiveness of the decisions you make. If you're approaching a latency problem by throwing more hardware at it, and that might be the right choice, you'll have a way to justify that and point to why you had to do it. If, on the other hand, you did it by rebalancing a cluster because something was improperly initially provisioned, or you changed the way you set up DRS, that increases utilization and would be reflected in the utilization curve matched to the latency curves. So this kind of data is quantifiably provable for how well an infrastructure is performing and how high quality or low quality the decisions are that are driving that infrastructure.
How are you thinking of presenting this? Because the graphs look good and the figures look good, but an IT person is going to have a very low understanding of...
Yeah. This is where we want your help.
This is the challenge.
This is the challenge. It is data in our domain is very difficult for most people to grasp because they simply don't have time. They're compressed to spend the time, or they don't have the background in statistical analytics to apply to the data that they're looking at. It's really the core reason for our existence is to bring that interpretation in a consumable fashion. In this case, I'm calling it out, you're calling it out. This is very sophisticated. It is meant for really very sophisticated users who are staring at data like this on a regular basis. Our challenge and our desire to work with you guys is to figure out how do we bring that down to people who don't have that time and don't have that background to interpret what they're looking at. And we don't know the answer to that yet.
Because there's so many possibilities. You know, you could expand a cluster, but you could move a workload from one cluster to another cluster.
Yep.
That's yeah, many options.
But you, from that decision point, you would be able to measure the effectiveness of that decision and see that, and then see the accumulation of your decisions over time to see what's happening. So anyway, this is live. It's going. If you're curious about working with us on this, please let us know, and we can spin up a project at a moment's notice to help you guys out.
Somebody asked earlier, and again, it's wonderfully obscured. The question was around custom analytics for particular use cases. And this was a couple of cards we built for helping users size their environment for hyperconverged devices. So what you see here is CPU usage over the course of a period of time, consumed memory average, and IOPS. You have all the different vCenters that can be expanded to view all the hosts. And you see CPU cores, cycles, memory. You get a histogram of memory used from mean to peak with 99th and 95th. You get some storage metrics here. You get IOPS. If I went this way, you'd get network, average block size, et cetera, to be able to inform that decision. And then viewed another way, extrapolating some of those key metrics at the top with host level metrics again down here with a subset of what you saw in this one. Just another example of people building applications to sit on top of the CloudPhysics platform for these different sort of use cases that we're finding in the marketplace.